Good morning, Foxkilla. Can you hear me? Great, thank you. Da 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 da. This music is so calming. Yeah, I'd be very surprised if too many people showed up today. This is gonna be one of those video on demand kind of lectures. But good on you for being here, Foxkilla. Good discipline. It'll take you far. I wonder, we'll have to take a poll. I wonder how many people woke up at like 11 a.m. We had office hours at 9 a.m. and very few people showed up. Does anyone know what game that song was from? Very peaceful. Ish, why did you wake up at 4 a.m.? do not subscribe. Do not cheer, okay? Don't do it. That is not the point. I unlocked some emotes for you, I think. But you're paying for tuition already. If you're not paying for tuition, then you go right ahead and cheer if you want to, but yeah. Eesh, you were watching the League of Legends World Championships start at 4 a.m. Where are they taking place? Are they taking place in China or Korea? Interesting. You know, I recall that Nintendo's big meeting they had to unveil the Switch to investors, stakeholders in Tokyo. I believe they had that meeting at either 9 a.m. Eastern Time or 8 a.m. I can't remember. And it was because it's kind of that sweet spot where, okay, people in the West can be assumed to be up, at least people in the States can be assumed to be awake. Or getting up, and everyone in Southeast Asia can also be awake at that time too. You know, it's 8 p.m., 9 p.m. That's not particularly crazy. So it is very interesting how they kind of try and fit their schedule to different time zones they want to hit. So. More channel point rewards. I'm not sure what you mean. I think I'm only allowed to offer a couple different emotes right now. I think one per tier of sub. But then again, you should not be subbing. If you want to get some channel-specific emotes for free, you can use the Better Twitch.tv Chrome or Firefox plugin. And there are a small handful of things I created for the channel for that. Nothing particularly interesting. Channel points are free. You see, that might be true, but I still don't know what channel points are. So... Okay, this has got to be our lowest stream count yet, and I can't imagine why. We're watching stream, you redeem them. Oh, cool. Okay, so it's a way of supporting the channel without paying any money. That's great. Okay. Okay, ladies and gentlemen, We played 2 tunes this morning, and both of them of a very calming, relaxing nature. What is the song that you hear right now? We've actually played this one before. Can you remember what this is from? So this is the title and / theme music of Far Cry 5. A very neat game, very relaxing opening music, very sad in a way, but pretty cool too. This is the other song that we played this morning. Ba 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 ba. So calming. What is this game from? What is this song from? What game? Any idea? This is a classic game. Incredible game. It's not a water level. It's not a water-based game. Well, though there is a very poignant water level in this game. Have any of you played this game? This is from Star Fox 64. It is the stage select / menu screen music. And what's incredible is that this always plays when you begin the game, it always plays after the game. So no matter whether you succeeded or you failed, this is always the song that you come back to. And if you think about the kind of tone of this song, right? What it's trying to say, right? It just has this, this space, the universe is so large, right? It's infinite, right? Space and time, the universe. It's as if this game is saying it's okay to you, right? It's okay. That last round didn't go so well. It's okay. You'll get them next time. And it's just incredible. Music is such a powerful, powerful tool, and yet game developers sleep on it till the very end of projects. I do too, even in my games. So it's a true tragedy. But the power of music is something that you should not forget, okay? Okay, everyone, thank you so much for attending this lecture. I know that it's a particularly difficult one to be at, in part because you just turned in your Project 1 assignment. Congratulations, you did it, you made it. No matter how it turned out, don't worry about it too much, okay? I'll remind you, even though this P1 Gold is the largest turn-in, the largest batch of points you have seen yet, it is still not that much compared to the overall course and compared to the points that you'll be racking up on P2 and P3 in particular, okay? In fact, the last few deliverables of P3 are worth as much as the P1 Gold submission. So, if the P1 Gold did not go as well as you hoped, that happens to a ton of teams. You're not alone, okay? And in fact, I've seen teams almost completely bomb their P1 Gold, getting half of the points, 40 points, 30 points, and still come out with an A or an A- because they knock it out of the park on P2 and P3, okay? And many students, in fact, most students do, because by the time you get to P3, you've had the design lectures, you've had the technical lectures, you're moving fast, you're feeling good, and you have iterated and taken feedback 5 or 6 times on that game. So it's just fantastic, okay? So do not panic, do not worry. Focus on your feedback and not on your grades, okay? Don't focus on your grades, focus first on your feedback. So I want to actually share a really inspirational quote that I just love. The deadline for P1 in 494 in general is very tight, right? Deadlines are something that can feel very, very destructive, right? Oh my gosh, I've got this deadline coming up. Why does it have to be due this early? Why do I got to do this today? When you get up in the morning, why do I got to go work out? Why can't I skip it? I'll do the workout later. I'll do my chores later. I'll go study later, okay? Later. And someday never comes, right? Walt Disney had an incredible quote. right? Walt Disney, one of the most impactful humans in history. Everyone needs deadlines, he said. Everyone needs deadlines, even the beavers. They loaf around all summer, but when they are faced with that winter deadline, they work like fury. If we didn't have deadlines, we'd stagnate, right? So in other words, it's amazing what you can accomplish with a good deadline that you hold yourself to. So that is the power of those deadlines. Now, you need to be careful. You need to stay healthy. You need to stay safe when you pursue those impactful deadlines. And that's something that we need to get better at, okay? We need to become more efficient, and we're going to work on that this semester. Becoming more efficient, using design patterns better, escaping from your spaghetti code base on P2, right? One of the greatest things about Project 2 is that you know what you did wrong on P1. You know what a spaghetti project looks like. You can feel it. You can feel the impact and how that drains your time, and how draining time drains your ability to sleep, and how that just kind of compounds, right? It's a vicious cycle. Fortunately, on P2, you are free. You break free from that P1 code base, and you can start fresh. You can use the singleton pattern, the observer pattern, pub/sub, to create better and cleaner code bases that are easier for you to understand, that are more standardized, and allow you to experiment faster, to iterate faster, to get content in faster, and it just boosts your confidence. It feels great, okay? So please enjoy P2 when we get to it. That's enough of a tangent, though. We got a nice, fun batch of announcements for you. Your weekly dose of Bethesda. Bethesda, one of my former students, sent me this incredible clip. You might have seen it online. It is Todd Howard, the creative director, I believe the creative director of Bethesda, maybe even higher than that, talking about some of the incredible memory management techniques that they used on Elder Scrolls Morrowind, which was the game before Oblivion. So let's go ahead and watch this video really quickly.
Original Xbox, how are we going to get this to even work? And working with them, there's some great tricks that they taught us. I think my favorite one on Morrowind is you can actually, if you're running low on memory, you can reboot the original Xbox and the user can't tell. You can throw like a screen up. So when Morrowind loads, sometimes you get a very long load. That's us rebooting the Xbox.
It's called memory management.
Yeah. That was like the Hail Mary.
Okay, so the idea is on Morrowind, which was for the original Xbox, they are trying to get this big open world to work, right? Bethesda is famous for their large RPGs that maybe focus on quantity over quality, but that's, it still works very well for them. Anyway, their team was not humongous making these huge games, and so they had memory leaks, like many games do. And they had to deal with this. The original Xbox didn't have that much memory, and so how would the team deal with the fact that they have memory leaks, they have a huge game and not a whole lot of memory? So those memory leaks add up quickly and start causing major issues for the game and its performance, causing crashes, stuff like that. Well, their solution was, you know what? The original Xbox has this strange feature where you can actually throw up a screen, right? Any image you want. And then you can tell the Xbox to totally reboot, right? Which means flushing all memory, all RAM, and then reload the game. And the user doesn't know about it. It just persists the screenshot to the video the entire time. And so this is just an incredible, ridiculous technique. And I'll be honest with you, as funny as it might be, and as much as we want to laugh at Bethesda for doing and resorting to this kind of technique, the scale of the games they were working on and the tininess of their team, like they might not have actually had the time to go in and programming allocation to go in and actually solve those memory leaks. This might have been a very frugal and good idea for them to do. So very creative, a fun solution for sure, right? Imagine if we could do that on your 281 assignments. Just forget about the memory leaks. It doesn't matter. We're going to reboot our program in the middle of the autograder and make it happen. That would be crazy. But another one. We learned from the last IGDA meeting, the interview with my former assistant for 494, Michael Siciliano, that Bethesda's HR department, after speaking with Michael on the phone as part of a job application interview, took 243 days to get Michael a result, right? And decline the job application. 243 days. That's impressive stuff. Okay. So anyway, there's your Bethesda. Amazon, and a big announcement this week. Amazon is investing heavily in cloud gaming. They have a new solution coming out called Luna, and it looks like it's going to be very similar to Google's Stadia cloud gaming platform, except this will have tighter integration with Twitch, which I think will give Amazon a much more powerful boost when this launches. So, in other words, in case you were curious about whether the cloud approach to gaming was going to stick around or persist, or maybe Google would put out Stadia and it would flop a little bit and everyone would run away, it looks like the big institutional players, the big money, is saying it's here to stay, right? So you've got Google doing this, Microsoft with their xCloud doing this, Sony has PlayStation Now, and now Amazon is moving into it. I expect within a few years we'll see Nintendo announce something to this degree as well. Okay, it could be a part of their Switch 2 maybe. Another really impactful and very, well, not so impactful, but very cool announcement this week is that Amnesia: The Dark Descent and Amnesia: A Machine for Pigs have both been open sourced. You can find their GitHub repository. And you can go in and you can actually check out the code. One thing that immediately stuck out to me was if you, I think I'm going to the right place. If you go into the engine, well, this is not the engine area. Where is it? Can I find it? Yeah, maybe not. But anyway, there you can look through all the code. In fact, there are Visual Studio project files that you can open up in here, and you can actually build the game yourself, which is super, super cool. Flashback effect, Lux area flashback. Okay, how are the flashbacks implemented in this game? Well, here's the file that helps you understand how. Check collision count. So it's something that checks collisions, and there you go. This actually seems like maybe a flashback in Amnesia, the game. This looks more like scripting code to me because it's short and it only seems to deal with one specific cutscene. So I'm guessing they didn't use any scripting language in this game because that would be a more natural place to put this kind of thing, a bunch of Lua code. But anyway, I haven't looked into it. I might be wrong. Anyway, go look through it. It's really, really cool stuff. Due today, P1 Gold, congratulations again. Please take a little bit of time to relax. You only have a couple assignments releasing today. I know that sounds so weird out of context. Relax, you only have a few assignments releasing today. But these assignments are extremely short and very easy. They are only going to be writing a postmortem and then evaluating your teammate. Okay, that's it from now until Wednesday. So, using machine learning to create new video games. If you go into grad school after this in computer science or game dev, a particularly big field in PhD studies right now is machine learning and generative neural nets, right? So using AI to create new content, whether that be photos, whether that be animations, whether that be deepfake videos, or video games, as it turns out. I want to show you a cool video. I can't remember what lab built this. Oh, Google DeepMind. No, that's not them. It's not mine. Professor of Interactive. So Georgia Tech. Okay, so a studio out of Georgia Tech has created this system that essentially will create Unity games for you. Okay, so here's a cool. Actually, let's pause this. So here's one of the games they made. It's titled Death Walls. It is a platformer that was generated. And here's the level, right? It has platforming gameplay. You can walk around, you can move, you can jump. There are these death walls that move around, and if you touch them, you die, right? You have to restart. And so it's, the level design seems a little bit random, right? This is not particularly impressive. It is impressive that, a game was made and players can play it. But the level design seems a little bit random, doesn't it? But here's something else. I want you to see this other video because this is something that is much more impressive. Look at this. This is the second game that this model created. This is called Killer Bounce. And this is a game where the player actually has an interesting mechanic added to it. The player is always bouncing, and the player cannot stop. Now, that's not particularly interesting alone, but when you combine that with the fact that the entire game, even all of its platforms, are made out of destructible, like one-time use objects, suddenly you get something that's very interesting, right? So there's time pressure, right? Because every time you jump, you actually lose the thing that was beneath you. So you have to be thinking about, okay, what is my route through the stage? Where are my platforms? Because my platforms are the important resources here. How many do I have? Where can I stop for a while? Like right there, they just did. Where can I stop to do a little bit of planning, get a little bit more time? And what kind of jumps do I really need to execute perfectly? Like there's a lot of great stuff here. And I can see this being, if you polished it up, I can see this being a very effective P2, a very effective P2 prototype. Very simple ideas. You can never stop jumping, and every single thing in the game goes away when you jump off of it. That is a very potent combination. I bet you could create some incredible puzzles using just those two mechanics. Anyway, it's very, very cool stuff. It's probably not going to take your job anytime soon, but as we've seen on titles like Ghost of Tsushima, where the level designers used kind of generative AI to create their landscapes and then tweaked them by hand to make them perfect player experience. AI is really becoming kind of an assistant, a better and better tool for game developers as time goes on. So anyway, very, very neat stuff. You might be doing this if you go to grad school. And I think you've already seen the truly efficient deer head, the wolf head, sorry. So we'll skip that. Something that you might want to do. So these games, the P1 projects, were just posted to the Project Progress channel in the EECS494 Discord. If you don't have a Project 3 team kind of in your mind yet, kind of solidifying, if you don't have contacts you're making, I recommend you go through and you do that, starting today. You got a few weeks until Project 3 starts. And Project 3 is the most impactful project as far as your grade is concerned. It is the place where a high-quality team, a team you work well with together, a team that has similar interests, a team that is full of people who have their schedule figured out and who have done well on previous projects. If you can get that team, you're going to be in a very good place, okay? So go in, play those projects, give feedback, right? People love to receive feedback. And start to think about, okay, who would I want to consider working with in this course, okay, for P3. So ask yourself that. Ask yourself if your current partner would be a good P3 teammate. If it just didn't work out, hey, it should be, no offense, hey, just business, right? If it didn't work out, there could be a billion reasons why your P1 team didn't work out. If it did work out, then you might want to start talking like, hey, you want to team up for P3? If so, let's find another team of two that did a really great job. So that kind of thing, all right? So now what I want to do is I want to get some feedback, okay? I love feedback. Thank you so much for filling out the forms to give feedback on each assignment. We see those, and we're going to use those for the subsequent semesters. Feedback, remember the iterative design process. It's really hard to make something better over time, consistently, if you can't figure out where you are, can't figure out what your problems are. And you get that by just being very, very, just go and get your feedback, be very, very emotionally calm about it, and just take it as it comes. So what I want to do is I want to get your thoughts on Project 1. I want to know, how did it go? What are your overall thoughts? And then most importantly, if you were a staff member on 494, with what you can see, what would you change about the project? Okay? What would you change about the project? I'll give you about 60 seconds, chat, to throw in your thoughts on Project 1. This is your chance to get revenge on P1. By fixing it. Introduce animation in class. Yeah, the animation system is something we talk about in the tutorials you do, but unfortunately it's not something we heavily cover in a lecture. And we could do that. We could maybe fit it into the lecture on collisions and triggers, which is, I believe, our second lecture. The animation system is a pain in the butt. I'll be honest, for games as simple as Metroid and as simple as Zelda, I usually would not use the animator. I would use an array, a public list of sprites, and then I would just increment an index integer to just kind of go through those sprites if it's an animation. One of the really cool things, team, is if you have a character that looks the same when that character's looking right, or you're right, as when they're looking left, what you can do is you can take their visuals game object and you can just set its X scale to -1, and it will just flip them, right? It will just flip them like that. This simplifies all your animation code and your animation logic quite a bit. So animations hurt. One of the reasons, if you want to know why we even have the animator at all in the tutorials, it's because the animator is very useful when you have more complicated animations and when you have 3D animations, which you very well might have later on in the course. So that's an instance where we want to get you that knowledge early, even though there might be a slightly less over-engineered way of implementing that stuff for P1. So that's the reason why that's there. Maybe not have it due during Yom Kippur. I mentioned that earlier. I can only imagine the stress. I did not see that. I did not see that statement earlier. But yeah, definitely put that into the feedback so we can kind of schedule around that for next time. Yeah, that's a useful point. Thank you. All right, so we're going to move on. If you have additional feedback, click that feedback button in the assignment specs, and that could help us. There were some things included in the tutorial we ended up having to throw out later in the game. I think one was hacking a rest animation by stopping the animator, making it impossible to attack standing still. That, with the new input system, it might be good to revisit and update the tutorials. Yeah, we'll definitely consider doing that for next semester. The tutorials are pretty old at this point. So awesome. Thank you so much, team. That's really, really useful stuff. Okay, so let's keep going. I want to briefly go over the assignments that you have launching today. First is your P1 postmortem assignment, right? So there are a lot of really, really great postmortems out there on the internet. You can find them. If you wonder what a postmortem is, essentially a postmortem is a blog. It's a blog post in which you basically write up how the development of a game went. So here's an example. Naughty Dog's first game was Crash Bandicoot, and the creators, Andy Gavin and Jason Rubin, Jason Rubin is actually a Wolverine alum, created this dev blog after the game came out to kind of talk about, okay, how did the game go? You know, what were the challenges in the creative process? Where did the team end up spending all their time? What were the technological breakthroughs they had? And what can they carry on to future projects? And so they have this incredible, incredible blog that goes through all of the challenges they faced in the early days of the PlayStation. And you can find a ton of different postmortems out there. Just do a search for, Google search for a video game postmortem, and you'll find a bunch. But anyway, the point of doing this kind of thing is, they say you learn the most from the mistakes you make. And in practice, that isn't always true. You learn a lot from your mistakes when you deeply analyze and consider them. And that takes time, okay? So sitting down over the course of a few kind of relaxed days to think about, okay, project one, it started really well, but then it kind of fell apart because we used this approach that really did not scale, and I wish we had used a design pattern, but I didn't really understand it until it was too late. Right, and for future projects, I want to use the design pattern, and I want to avoid the animator, and I want to do this and that, and I want our communication on our team to be through Discord instead of through Slack or instead of through email. Right, these are the kind of things that really, really power you up, not only for the next project, but as you move into industry, as you move into academia. Looking back, is how you move forward, okay? So you're going to be doing that. P1 postmortem, it's a really, really short essay assignment. You're given a template. It's just 2-paged, double-spaced, which means you can knock this thing out in like 20 to 30 minutes if you really want to. And you're just going to answer these questions, right? So read the question, describe the 3-week process that led to the creation of the simple game, and you just kind of delete this and then write the answer. Boom. Once all the red text is gone, you have your essay. And that's it. You're going to be thinking about the development and iterative process. You're going to be thinking about the custom level, and you're going to be thinking about what you can do for Project 2 and Project 3, okay? A very valuable section here. I know that your mind is already flowing with things that you want to get out onto paper, okay? So please don't be fearful of really saying how you feel, okay? Be honest with yourself. That will really, really help for your P2 and P3 assignments, okay? Okay, does anyone have questions on that assignment? But is the postmortem an individual assignment? So for the postmortem, you do that with your partner, okay? Maybe you have feedback and thoughts in your head that you don't want to share on the shared postmortem, and that's fine. Just keep those to yourself in your head, and if you want to, you can actually put those into your next assignment, which is the P1 peer evaluation assignment, okay? Who has heard of a game called Narbacular Drop? Anyone? Okay, so it looks like no one. Who has heard of a game called Portal? Anyone? So Portal's first version was called Narbacular Drop. It's here on the left. It's a puzzle game in which you use the portal mechanic, because it did exist first in that game, to kind of navigate through this labyrinth and solve navigational puzzles. And what's really incredible about how this happened was the DigiPen team. DigiPen is actually very close to Bellevue, Washington, where Valve is. And so when they were exhibiting this game, Gabe Newell came through, saw this game, absolutely loved it, and hired the entire team, the entire student team on the spot to work at Valve and create Portal, and they did. So essentially what happened was that the team was interviewing all the time, okay? When suddenly Gabe Newell came in and said, you know what, you're perfect for what we want, and they just hired him. In other words, from here on out, you are always interviewing. As my mentor, Jeremy Bond, used to say when he was teaching this class, you are always interviewing, okay? It doesn't matter if you're just talking with someone on the street. It doesn't matter if you're having pizza with someone and chatting. It doesn't matter if you're showing off your portfolio in the Project Progress channel. It doesn't matter if you're at the EECS494 showcase. You are always interviewing, and you never know who might be watching, okay? You never know. The Stardock team could be watching and looking for a new hire, right? We have a bunch of contacts now at places like Sucker Punch, at places like Sony Santa Monica. We have a lot of at Microsoft on Halo, at Mojang. You never know who's watching, so you're always interviewing. In other words, P1 peer evaluation. Your contribution to your teams is going to be something that defines your reputation, okay? And that reputation will spread. So please be sure you're contributing and being very congenial and easy to work with your teammates, okay? This is an assignment that is very easy and very short. Well, it might not be that easy, unfortunately, if you have to say something negative. But essentially, you're going to go to this form. You're going to fill it out. You're going to enter your teammate's unique name. You're going to rank them from 1 to 3. 3 being, hey, they met expectations and they were relatively easy to work with. You put a 3. If you were unhappy with how things went, you put a 2 or a 1 if things went really poorly. And if you put a 1 or a 2, I'm probably going to investigate and generate some reports to make sure that they contributed and apply the imbalanced team penalty if not. So anyway, this is your chance to give feedback, and please put notes as well. So if you're not happy with your partner's contribution, explain why in as much detail as you can. Okay, your partner, your teammates will not see the score, but unfortunately, because the team size is so low, like they will essentially know if you're ranked low. Don't let that stop you. Okay, they can't do anything. But be honest. Okay, if your teammates, were relatively decent to work with and did a relatively okay contribution, give them that 3. Reward them for that. Okay, and please also consider that there might be reasons why your teammates couldn't contribute as much as they wanted to. Okay, so please take that into consideration when you rank them, because there are a billion reasons why someone might not be contributing to the team all that much, and low effort is simply one of those. Okay, so anyway, let's keep going. Does anyone have any questions? Oh, yeah. So you can evaluate your team if you want to. If your teammate dropped in the middle of the project, you can evaluate them, but it's not going to be very meaningful. So you might... Yeah, I would just evaluate them so you can get your 5 points for filling out the form. But otherwise, I would not do it. Does anyone have any questions? Does anyone have any questions on either of these 2 assignments? Okay, so let's keep going. Feel free to ask a question. We'll get back to them during the break. So what I want to do is, last time I attempted to show you about lighting in Unity. Lighting is an extremely powerful thing that can help you forge new game mechanics. As we saw in Left 4 Dead, it can actually also help with guidance as well, as players tend to go around and will follow light and go to light. It drags them along. Also, consider earlier when we talked about poker. Remember, poker, part of its engagement, right? Part of why its decisions are so interesting is that it is a game of imperfect information. You can't always know in poker what your competing hands are, right? You don't know whether you have the best hand of the bunch. And you have to kind of try and surmise that based on how your opponents play. And so poker is a game of imperfect information. That is a big element of why it is so engaging and long-lasting. Consider this, okay? In poker, it's a game of limited information because you can't see your opponent's cards. However, how could you create a game of imperfect information outside of the poker or card game context? So it's a real-time action game, or it's a horror game. How can you create a game of imperfect information? Well, darkness is a really, really great way of doing that. So what I want to do is I want to show you a quick way. Hopefully we won't crash this time, because I have 20 gigs free on my hard drive. It's the most I think I've never had so much free. Just for this. So what I want to show you is some very basics into how you can begin to play with and experiment and explore with lighting, okay? So let's go ahead and check out this game right now. This is a game that I quickly made for the... you can hear the... listen to this ambience. You can hear the cry of the whale, right? So this is a game I made for my UArts freshman level course. It's essentially rollerball, but we have an invisible ball and we have this whale object that follows it as kind of a view in the model view controller style, and points in the direction of its velocity, right? So we can go around, and if you notice, the lighting in this scene is really neat. It gives this kind of, awkward kind of, spooky ambience to the game. It begins to remind me a little bit of a more abstract Silent Hill here. Or maybe we're up in the clouds. That would be really cool. And add that, hear that ambience? Add it to a little bit of space ambience, and you get this really spooky atmosphere. Anyway, if you wanted to play around with this aesthetic, you could do a few things. Let's say that we wanted this to be more of a horror game. We wanted to set it at night instead of in the fog, okay? Let's go ahead and do that. So what you'll notice is that in Unity, lighting is powered by actual objects. You can actually see them in here. Lighting, right here. And if we turn them off, something will happen. So let's go ahead and fly over here to where we start the game. And we are currently rendering lighting. So we've got this light tab on in our scene view. So hopefully when we turn off these directional lights, we'll actually see that the view has changed, right? Okay, so we turn one off, it's very dark. What does this other light do? It's a less powerful light. Is it in the same direction? I want to see. Where is it? This one is straight down, and this one is at an angle, it looks like. So, yep, it's at an angle. Okay. So let's go ahead and turn both of these off, and we've got this really dark scene. Okay. However, what we'll find, and what you'll find as well, is that this doesn't actually do much, does it? I mean, the scene is a little bit darker, but we still have the skybox, which is pure white over here. We still have the fog, which makes it look kind of strange, okay? We're kind of caught between daytime and nighttime, so it looks kind of uncanny if you look at this image. In fact, this looks like a Z buffer. This looks like a depth buffer image, now that I think about it, for any of you graphics whizzes out there. We'll talk about graphics a little bit later on in the course, and shaders and SimD later. So the problem is we still have light in this scene. Even though we have no lighting objects and no lighting components in the scene, we still have light. We have ambient light, okay? We have light that is coming from the skybox. So what we need to do is we need to go up to Window and Rendering. This situation always frustrated me because I wanted to make a pitch dark game so that I could build it up from scratch, build the lighting my own way, but the ambient lighting kept getting in the way. So you're going to go to Window, you're going to go to Rendering, you're going to go to Lighting, and we have all these different options here. We're going to want to go to the environment, because right now the environment is creating lighting aside from what our game objects create. We're going to take our skybox material, we're going to say, you know what, just go away. Okay, now we've got a skybox that's much simpler. You can see it has changed. We're going to get rid of the sun source. We're then going to go ahead and change our environmental lighting from the skybox to a color. We're going to set that color to pitch black. You see, it's not really helping a lot yet, but now we need to turn off the fog. In fact, don't turn off the fog. Let's get some dark fog going on, okay? So let's go ahead and play this and see how it looks. Ooh. That's pretty cool. That's pretty cool. Wow, this really, I love the contrast here. This looks like a painting, some modern art. We could just frame it. Look at this. Payment, screenshot there. Boom. That's beautiful. Okay, so anyway, what we need to do is we can still see the skybox, right? When the camera takes a pixel and discovers that there's nothing in front of it, no tangible object to render to, what it does is it says, you know what? I couldn't render a pixel from any object, so we're going to render the skybox instead. We're going to render the skybox. What is the skybox on this camera? The camera says, the background, the skybox, is a solid color, and that color is white, so that's why we're getting the white. Let's go ahead and turn this to black, pure black, and see what we can see. Hopefully nothing. Hey! All right, look at that. What a game, huh? So we can see nothing right now. And that's a bit of a bummer, right? In fact, we can barely see in our scene view. So I'm going to turn off lighting so that I can actually work here. And what we're going to do is we're going to create and start to build up the lighting in our scene, okay? Forget about directional lights. Those are too all-encompassing. What we're going to do is we're going to right-click, and we're going to go to 3D. No, we're going to go to Light right here, the category. You can also go to Hierarchy, Create, Light. And we're going to create, what do we want to create first? Let's create a point light. Okay, let's create a point light. So a point light is sort of like a light bulb. It is this sphere that kind of emits light in all directions, and you can actually see the sphere that is emitted right here and where it's emitted from. Let's go ahead and let's adjust this while we play, because it's hard to gauge the light. Actually, we can turn it on here. Ooh, look at that. There we go. Right, look at this. Look at this. So if we play the game right now, we should start just on the edge of this little dome. It would be very nice if we could create like a pole or something in the environment so that we have some notion of what's causing the light. Wow, that is not bright enough at all. Let's experiment while we play the game. We're going to increase its range and its intensity a little bit. Wow, look at that. Look at that. The only problem with this light is that it's not obvious where it's coming from in the environment. So what we're going to do is we're going to copy this because I don't want to lose those changes. We're going to paste in that light again, delete the old one. And now what I want to do is I want to really quickly just create a little pole here. So let's go ahead and go in. We're going to grab a, can we get a cylinder going on? Hey, there we go. Bring it back to the origin so we can place it. We're going to hold control as we move it around so it snaps, right? We can snap it to make it look nice. Okay, it needs to come down. One more snap. I think one more snap after that. Good. All right. So now we're going to move this thing around, and let's go ahead and bring it out here. Maybe this is like a, maybe if this is a city, this is like a garbage can that's on fire or something. Okay. We're going to parent this point light to our cylinder. We're going to take it to the origin. We're going to move it to the top right here. Okay. And now what we have is our flaming trash can. I'm going to call it that. Flaming trash. Flaming trash. Nothing but garbage. Okay, now we can move this around and kind of paint our environment with this cool lighting. It all looks a little bit more natural because it actually has an obvious source where the light is coming from now. So we can move things around, and let's go ahead and move it around here. And let's see, so right here at the little junction there, get it off to the side like a garbage can should. And there we go. So let's go ahead and play the game and see how it looks now. Yes, very hot garbage, and I wouldn't have it any other way. Why are these not working? We're going to investigate. Can you believe it? It's not working. Let's go ahead and check it out. So, oh, you know what? I went in the wrong direction. That's why. So let's go ahead and move some of these out here. I think I just trolled myself a little bit here. Let's see again. This is why you have to playtest constantly, okay? Because if you notice that something isn't working the way you want, you know for certain like what the last thing was that you changed, which makes it much easier to refactor and get to where you want to be. So is it out here? Let's go over here. Venture out. Oh, yep, there's our new light right there. I think we need to increase the range if we want to be able to see the light from across. By the way, this is why you want to use prefabs. Unfortunately, we have to do this if we want to increase the range on all of these. We have to open them all up. If we had done a prefab, like we should have, then we could change it in one place and be fine. So what I'm doing right now does not scale. This is bad, very bad, and I do feel bad. So, okay. So we've increased the range a little bit. You know what? Let's make it red. Let's make it a little bit ominous. Ooh, look at that! Look at that. We are in some sort of underworld, chat. Not sure what got us here. I think releasing P1 on such a tight deadline is what got us here. But yeah, there we go. So anyway, here's something I want to do. Let's say that the game has some portions where there isn't a whole lot of lighting. Okay. Let's say that there are areas where there isn't a whole lot of lighting, like this dark corner right here. Well, we might want to do something where, hey, our player object has a light that always follows them around, okay? And a lot of games will do this. They will have a light that seems to follow the player, whether that's a flashlight or whether it's an overhead spotlight, okay? So let me go ahead and get this whale to be still here. What I want to do is I want to create a new object. We're going to go over to our player. Where is it? There it is. Player view. That's the whale right there. And what I want to do is I want to create a new object. But what I want to do is I want to create not a point light, but a spotlight. Okay, a spotlight. You know, whereas a point light is more like a flashlight. A point light is more like a light bulb. A spotlight is more like a flashlight. And maybe we'll be able to see it. Maybe it has to render. Ah, there you go. Yep. So you can see if we look closely here. Do you see that, chat? You can see that outline. We can make it more powerful if we increase the intensity or range. And we can also make this angle wider too. Okay? What I'm going to do is I'm going to create this light. And then I'm pretty sure I have a follow target component. I'm going to tell this follow target component to follow. What should we follow? Let's follow the player view. So I'm going to drag the player view in. That's the whale. I want you to follow the whale. I want you to stay above the whale, exactly above. I want you to stay, how about 5 units above the whale? Should look at target during cutscenes, yes. Should follow during cutscene, yes. Should look at target, yes. Should look in direction of movement, no. Okay, so let's see how this looks. Hey, would you look at that? All right, we have ourselves a spotlight, which is really cool. You could, if we point this in another direction, like in front of the player, we could have a flashlight, okay? So anyway, we've got some pretty cool stuff going on. If you then wanted to say, you know what, it's not quite pitch black, there's a moon out. There's a full moon, so we do have a little bit of kind of global light coming down. What we can then do is we can create our other type of light, which is the directional light, right? However, because it is in fact nighttime, we do want to make that a much lighter and less powerful source of light, okay? So we got a little bit of lighting going on, not a ton. How does that look? That looks a little bit better, and maybe over time you could have it brighten up as daylight comes, or maybe we could make it a little bit blue to give you that kind of Arctic or lunar feel to it, or maybe golden, right? Oh, look at that. Wow. I love that golden look. Look at that. All right. So anyway, this is just kind of the beginning of how you can get basic lighting experimentation going in Unity. Now, Unity actually has some very, very powerful ways to, some very, very powerful lighting models that can help you get hyper-realistic aesthetics in your game if you want. Unity HDRP. It's the high definition render pipeline. I work mostly in mobile games and in browser games, so I don't tend to use the high definition render pipeline, but you can get lighting like on this level of quality with incredible reflections and what is it called? Something occlusion, ambient occlusion, the shadows, right, that appear in the wedges in your room, right? You can get a lot of very realistic aesthetic effects going on if you use the high definition render pipeline. But things you'll have to do some tutorials on it. I'm not sure if we're going to cover that this semester. Maybe we will a little bit later. Anyway, team, ambient occlusion. Yes, I forgot the title. Why? Okay, so a question from chat. Why do you use a follow component rather than childing? So you could do that. You could parent it. We could take this light and we could parent it to the whale. But this is actually going to have some nasty side effects. So let's do it and see what happens. So here's our spotlight, and we're going to get rid of the follow target component. Instead, we're going to find our player view. We're going to parent it, okay, to the player view. Let's go ahead and look at where that is. So, okay, it's parented exactly how we would want it, right? So this is how you could do it, chat. And this will work, right? It follows us around, but then when we jump, something terrible happens, okay? When we jump, okay, the light rotates, okay? And this is why. When we jump, the whale actually turns, okay? When we jump, the whale's game object actually rotates to face upward. Well, the light rotates with it, okay? Watch this. As we go down, you're going to see what happens. The light, because it's parented, it has to rotate along with the whale. And we really don't want that, okay? So parenting is very powerful, but sometimes it forces you into things that you don't want, right? And if you parent your object to another object that happens to rotate, like that better be what you want. If it's a flashlight, that probably is what you want, because you want the flashlight to always be facing forward, even when your whale, your object, your player avatar rotates. But if you don't want that to happen, if you want it to be like a following spotlight, then you really just want it to be a separate object that just kind of follows around, okay? In other words, like writing the logic to have a game object follow another one with an offset, it's super easy. It's a short component. It works super well. You can linearly interpolate it if you want to follow smoothly. But if you parent, you lose pretty much all those things, okay? So I don't like parenting, right? I don't do it very much because of those restrictions, okay? That's why. Okay, so awesome. Let's keep going. I don't want to talk about lighting anymore today. It's a very fun thing to experiment with, though. I highly encourage it. I want to talk about some other topics. I want to talk about the Unity Asset Store, and I want to talk about using external assets. Wait, Prof confirmed doesn't want kids. Talk about lighting? I didn't mention kids. Anyway, so let's talk about Unity Asset Store. Okay, so one of the really cool things about getting out of P1, you did a little bit of this on P1 Gold maybe, but P2 and P3, you are permitted to go out and find assets that are external to your team, okay? That means you can go out and you can find, open source graphics, you can find open source models, you can find open source textures, you can find open source music, sound effects, all of that. And you can bring it into your project as long as it's not copyrighted and as long as you still made most of your project, okay? So I don't really want you taking an entire project, downloading an entire project from the Unity Asset Store, for instance. Don't do that, okay? We want you writing most of your own code, okay? And you must document, you must always tell us when you haven't created something. You must go credits.txt, put it in the root of your project so we can see what you created and what you did not, okay? The Unity Asset Store is a really great place to do this kind of thing. You can go to Window, you can go to Asset Store, and it will tell you to search online depending on what your Unity version is, okay? You'll click that button, and it takes you to the Asset Store, and, there you go, right? So we're on this Asset Store, we're logged into our account. What are you feeling, chat? What do you want to find? Let's find a nice duck. We need a duck for our game. And let's see here. Oh, look at all these great ducks. Wow, these look fantastic. However, they are paid, okay? I don't want you paying money in this course generally, okay? We took the textbook out of this course to reduce the cost of it. We don't want you paying for anything, so here's what you do. You go to pricing, and you set up a filter. You say, free assets only, please. And you can find free assets. So there's this animal pack. There's a farm set. There's another farm set. There's a low poly duck set right here. So there's all this great stuff that you can get. This might seem a little bit limited, but maybe for other objects it's not so limited. Another really great place to go is opengameart.org, okay? So opengameart.org is a spectacular website that has a bunch of assets. So let's search for a duck here. Okay, so we got ducks, but you know what? I don't want sound effects, okay? Crazy duck melodies. Okay, I have to listen. All right, it's not really doing it for me. So we don't want music, so let's turn off the music. We don't want sound effects, we don't want documents. Let's just stick to concept art, 2D, and 3D art, okay? So we can click that, and hey, now that's all we get. We got this cool 3D duck model we can import. We've got 2D aesthetics everywhere. We got some sprite sheets even. That's really cool. And so you can use OpenGameArt to find a lot of great stuff. And I encourage you to use it. However, you must always credit in credits.txt, okay? So that we know what you created and what you did not. Many teams, what they'll find is that they create like half of their graphical assets, and then they go out and find the rest, okay? There are other websites too. There's this really great Google document that you can get on this agenda with a large set of websites dedicated to free textures. So if you want to make a game that's a little bit more realistic, you need to find realistic textures, realistic high-definition textures of like ground and gravel and floor tiles and glass, right? And so you can find them here. Okay, what are we looking for? I'm looking for some good old-fashioned dirt. Hey, there we go. Look at that. We got all these really fantastic textures for dirt. And what's really cool is it usually comes not only with the albedo, like image texture file, but it will also come with other stuff like a height map or a reflection map. And so you can actually create extremely realistic surfaces using this kind of stuff, okay? Anyway, so that's another resource for you. Another great one for specifically sound is freesound.org, which has a ton of different sound files that you can use. Okay, just remember to credit. Okay, so yes, so part of the reason, as a little discussion on this, part of the reason a product or an IDE or a piece of hardware succeeds or fails is because of the community that it has. And by community, I mean if you Google, Raspberry Pi error, right? You will find like countless pages of people who have found your error that you ran into and also found ways to solve it. You'll also find tons of software that you can add on to the Raspberry Pi. Part of the reason that the Raspberry Pi is so successful as a little mini single board computer, right? It's not the most powerful for its price. It is cheap, but it's not the cheapest for the amount of power that it gives you, but it does have one of the best communities out there. It is extremely easy to get going with the Raspberry Pi and find documentation and get your problems solved. Not the case with some of the other solutions like the Orange Pi. And so, anyway, Unity is one of those ecosystems that has a really great community with lots of support, lots of documentation, and lots of fantastic free assets for you to use too. So please make use of this community. And in the future, when you're choosing where to make your next experiment, where to make your next portfolio piece or product at the company you work at, make sure to look at the community that you'll be working in, okay? So you want a healthy and very rich community full of stuff and useful documentation and people doing cool stuff in it, okay? Cool. All right, so I won't go into too much detail here, but you will, for Project 2 and Project 3, chances are you will want to use not the Unity like input.getAccess system. You'll want to use the actual Unity input system to work with controllers, okay? Chat, how many of you want to make a game based around a controller with a controller input scheme, or maybe a multiplayer game? How many of you want to make a multiplayer game for your Project 2? I'm curious. So it looks like we have quite a few people who want to do multiplayer or use controllers at least. So if that is the case, then you will want to read this document. It essentially explains how you can get started super fast with using controllers, okay? Unity's input system is different from what you probably used on Project 1, which was the input manager. Input.getAccess, input.getKeyDown. That's not going to work, okay, if you want to do multiplayer. So what essentially happens is you will use a new class called gamepad, okay? You can use gamepad.current to get the current active gamepad, right? This is really good for single-player games. A gamepad is a data structure that you can query. If you look at this, you can see active gamepad, which is an instance of the gamepad class. This represents a controller. You can then say, hey, .a button, right? A button is always the one closest to your thumb if you just let it rest, right? It's the one directly under your thumb at the bottom of the controller. And then you can say like, hey, button.was pressed this frame, button.was released this frame, button.is down, button.is up, right? And so the API is kind of similar to what you've been used to. Input.getKeyDown, right? Button.was pressed this frame. And so you can use it that way. If you want to get multiple controllers, for instance, if you have two controllers plugged in, right, so two players, what you can do is you can look at the array, the global array of all controllers, which you can find here. Gamepad.all will give you an array or an IEnumerator of all controllers, or IEnumerable, and you can put that into a list. You can look through the list, you can index into it. At index 1 should be your second controller, at index 0 should be your first, and you can just query the controllers that way, okay? And I think that's how most student teams in 494 use the controllers, okay? And so this, I think you'll find it to be very nice when you use it this way. You can also do, what is it? It is, it's just a magical thing. Unity Rumble Input System, Rumble. Oh yeah. So what you can do is you can enable Rumble support by implementing set motors. I think it's called set motors. Let me see here. Left stick, D-pad, right stick. What's the function name? Come on, help us out. Current pulling. No. Rumble, bingo, set motor speeds. So you're going to grab the current controller. You're going to set motor speeds. And most controllers have 2 motors. There's one on each side. So you can go ahead and... actually, wait a second. Is that the case? Is that how this works? So essentially what you do is you tell the motor at what frequency they should run. And they will continue to run that way until you tell it to stop or run at a different frequency. This creates an extremely common bug where you set the controller to vibrate, but then your character dies or the game turns off. And so you have told the controller to vibrate, but you never told it to stop. And so this is called a rumble bug. It is extremely common. And it is a bug where your controller just starts to rumble essentially unto eternity. Okay? So be careful about that. If you enable rumble, please do consider using rumble if you have a controller-enabled game. It really adds a lot to the feel of a game, which is at the core of how much fun your game is going to be, right? Game feel, juice. We haven't talked about these things yet. We will. Next lecture, I think we're going to talk about juice, okay? So anyway, what I want to do is we are at, oh, and by the way, really quickly, most modern controllers have the same layout, okay? It is a long time since we got controllers as weird and unique as this, okay? This is history. So most controllers have the same layout, 4 buttons, 2 sticks, and a D-pad, and some funky buttons in the middle. And you'll see that. That was the PlayStation 4 controller. Here's the Xbox One controller, 4 buttons, 2 sticks, a D-pad, and some miscellaneous buttons in the center. You've got the same thing with Google Stadia, right? You have the same thing with the Amazon Luna controller. You have the same thing with the Xbox 360 controller, a classic, and you have the same thing with the current Nintendo Switch Pro controller. So there's not a ton of creativity going on with controllers these days, though some of them have touch controls and stuff like that. Anyway, this input system is going to make it much easier for you to make your game work with a variety of input devices. Something that you should consider, though, is if you decide to do a multiplayer game this semester, you can't go to your friend's house and play this, right? You know, we can't have an in-person playtesting session this semester. So what you're probably going to end up doing is you're probably going to end up using something called Parsec, okay? Which is a pretty awesome piece of software. Parsec is a program that you install that essentially takes your friend's inputs, sends them to your computer so that you can pretend that there's someone sitting next to you, and then it beams them the image coming from your computer, okay? So essentially it's a way of faking local multiplayer, but everyone is remote. It works pretty well for the most part. It's not perfect, but this is the easiest way to do multiplayer in this course, unless you want to do actual dedicated online multiplayer client-server approach, right? We'll probably talk about that a little bit more toward the start of P3. We might introduce how to do some basic online multiplayer, but it is a very, very challenging topic, and we could easily dedicate an entire course to it. This is going to be a much easier way to go, even though it's not going to be quite as fun or user-friendly, okay? So anyway, does anyone have any questions? I'm going to give you 5 minutes, chat. We're going to come back with some game design on the topic of feedback loops, an extremely fun lecture. See you in 5. Feel free to, I'll throw some music on. Feel free to ask some questions if you want, and we'll get back to it, okay? Does this generalize to keyboards as well? Are keyboards treated also as gamepads? Unfortunately, the answer is no. I think there is a way that you can set up a mapping pretty easily. However, the most straightforward way with the knowledge you currently have is if you, for instance, want to make a game where one player is keyboard and one player can be controller, you might want to stick and use both systems. So you'll use the input system, gamepad.current.a button was pressed, right? you'll use that for the controller player, and then for the keyboard player, you'll probably stick to what you used for Project 1. You already know that very well, so it'll be very fast. You can use, wasta w dot was pressed, a dot input dot get key code dot a, right? If you want to pull the A button, stuff like that. That would be the most pragmatic approach. Anyway, I'll throw some music on. Let me see. Yep, going through. Okay. All right, what should we listen to? I need some pop. I need some energy right now. So let's go ahead and get what should we do? Let's do Mountain Stream from Kirby 64. I don't know if the GameCube is supported. You know what though? I have to imagine that you are not the first person to try. Like, I think that the question is going to be has Unity built-in support for that particular controller? I know that the input system will recognize a lot of controllers. I think it even recognizes the DDR dance pads. But whether or not it can handle the analog shoulder buttons, I'm not sure. That would be very cool, though. That would be extremely cool. I would test it, to be honest with you. Here's an important point. You want to make sure that your game, if it uses controllers, will work with an Xbox 360 controller. This is an Xbox One controller. They're essentially the same. You want to make sure it works with an Xbox 360 controller, because that is the kind of standard grading controller for this course. The instructors all have those controllers, or if not yet, they will have those controllers. So you can verify that the instructors, when they go to grade your projects, they will have the same experience that you have locally when you test it. Okay. Mario Sunshine for the Switch doesn't support GameCube controllers. That's a pity. I know that the 3D Mario All-Stars collection's been getting some flack for being kind of a quick port. I didn't know it was that slapdash. That's disappointing for sure. Can I turn the music volume down a bit? Yeah, I did. Is it still too loudish? I noticed it was going into the red on my OBS. My favorite controller is probably the GameCube controller. That's the one I spent much of my childhood growing up on. And however, I do really admire the Switch controllers. The Joy-Cons are extremely unique. And they offer something I think no other controller has, which, you take the two pieces of a Joy-Con pair, and you instantly have a simple local multiplayer setup, right? And that is exceptional. Those are easily the most innovative controllers I've seen in a long time, certainly of this generation. I also really like the Xbox One controller and the PS4 controller as well. The DualShock series is so consistently excellent. Ever since my first console was a PlayStation, and ever since they've just nailed it with that design. Okay, so we're at 5 minutes, so let's get back to it, chat. This stage in Kirby 64 used to terrify me as a kid. This is the stage where it was very easy to get smashed by machinery coming up, going down. Terrifying. Anyway, and this in a Kirby game, right? They bring you in with the cute and cuddly graphics, and suddenly they hit you with a stage that is depressing and very scary. Okay, so let's keep going. I want to talk to you today about feedback loops, and maybe we can go into prototyping if we have extra time. So feedback loops, and you might already know the feeling. If this image inspires a certain feeling in you, right? Then you may be a Mario Kart player, okay? And you might know why Mario Kart is important in the context of feedback loops. So let's keep going. I have a question for all of you, chat, and I need your help, okay? What do the following all have in common? Okay? Let's start. What do the following have in common? Progressive taxes. Okay? Progressive taxes, what do they have in common with dampening forces? Okay, this is the displacement graph of a spring, right? So a spring, right? It's all stable. You pull it apart, and over time it comes back to neutral, okay, to that resting, stable state. And Mario Kart, mamma mia, okay. So chat, what do taxes, progressive taxes, dampening forces, and Mario Kart have in common? They are things people evade? No, Mario Kart is one of the most popular series on the planet. It is one of Nintendo's gems. Chat, think about it, okay? Mario Kart. Dampening forces, look at this curve, how it comes back to the pack, right? And progressive taxes, where the more you make, the more you pay, right? Destroy the normal life you got. So chat, this is the deal. These are all instances of negative feedback loops, okay? They're feedback loops, powerful ones, and they're negative, okay? Balancing feedback. In other words, it's a feedback loop where what you do brings it back to the pack, right? The output of the system balances the system, okay? Here's the technical definition from Wikipedia, okay? Negative feedback occurs when some function of the output of a system, process, or mechanism is fed back into the function in a manner that reduces the fluctuations of the output, okay? And essentially what this means is the output of a system, it gets fed back into a system and makes the system more stable, okay? So progressive taxes, right? As you start to pull away from the pack and make more and more money in a year, you have to pay more and more, right? So the system is taking your earnings and is using those earnings to try and bring you back to the pack, right? Because the more you make, the more you earn. The more you earn, the more you pay, right? And if you don't pay much, and if you don't earn much, you don't pay much at all, right? Think about it this way too. The spring, right? So you pull the spring apart and it's really displaced. It's in a really unnatural position. You let it go, and the spring does its best to try and bring it back to center. And over time, it does. It brings you back to the pack, okay? The spring has a force that brings whatever perturbations you give to it back. Okay, in Mario Kart, okay? What happens to you in Mario Kart if you get way ahead of the pack? What happens? Chat, what happens? You get the blue shell. Right there, okay? If you are way ahead of the pack in Mario Kart, you get blue shelled. The items in Mario Kart that you get when you're at the front of the pack, they're really bad. You get bananas, you get Koopa shells maybe. If you are in the middle of the pack or toward the end, you get really, really good items, like the blue shell, which you can use to punish the player in front. This is often referred to among players and designers alike is called rubber banding. Okay? Because this game will try and bring you back to the pack if you are way out ahead. The reason this was put into the game was because the designers and playtesters discovered that if you are way ahead of the pack in Mario Kart, it's not very fun, right? It's just kind of a standard racer, right? There are no players nearby. You're not in a dogfight with anyone. You're just way ahead. It's kind of boring. Likewise, if you're way behind, it's also boring because there's no one around you, right, to use your items on. There's no one to get into a heated, engaging battle with. Oh, okay, I'm going to pass him. I'm not gaining, right? There's none of that excitement. It's all gone. The most exciting moment in Mario Kart is when you're kind of in a pack, right? And you're in a dogfight and you're super engaged because, okay, got to swerve around that person, got to hit them with the shell. Okay, I got to get an item box. But no, they just stole it right in front of me. Oh, right? And so the designers implemented these mechanics to establish negative feedback loops. If you're behind, the game will give you help. Will make you faster, will give you better items to get you back to the back. If you're way in front, the game will reduce your help. Will give you bad items, will help others catch up to you, okay? And the Mario Party remains one of the most successful and fun and engaging party games out there today as a result. Balancing feedback. So who has ever watched a game of soccer or football, right? And, you're watching it on TV, you flip the channel, and then you see this score, right? You see, it's like 7-1. Like, is anyone going to watch this game? Okay, this was the World Cup, and it was a historic blowout, so people did watch this game. Bad example. How many of you have looked at a basketball game, seen that it's just a blowout, right? Okay, Minnesota versus Wisconsin, and Minnesota is down by like 20 points. It's not very interesting, is it? You don't have a dog in the race. The game has essentially ended at that point, right? It's not very fun. Or a football game where one team is getting blown out, the game is effectively ended. It's just not very interesting. Well, these games suffer a bit because they don't have negative feedback loops in them. If you're playing a football game and you get ahead of your opponent, there's nothing in the game's design, in the design of football, that brings you back to the pack, that brings you back so that the other team has a chance of winning. There's nothing in the design that does this. It still sometimes happens, but not very often. If a team gets way ahead, very often they stay ahead. It's not very exciting. Likewise, there's nothing that helps the team who's behind catch up. So maybe just the apathy of the other team, maybe. That's the best they've got. It's not a strong negative feedback loop. Let's take a look, because Left 4 Dead has comeback mechanics in it. Left 4 Dead has a strong feedback loop, a negative one, that brings you back to the pack. Whether you're doing super well, if you're doing super well, it will make the game harder. If you're doing really poorly, it will make the game easier and give you a break. Let's take a look at what the developers said about this. They use an AI director to change the game to make it easier or harder.
Based on the success of procedurally populating the world with wanderers and mobs, we decided to try to guarantee a consistent dramatic experience for the survivors. Through playtesting, we observed sessions where some survivor teams would occasionally get into a downward spiral of being overwhelmed to the point that they were never able to regroup and get ahead. This was partially due to some poor choices of the survivor players in varying skill levels, but also due to the luck of the draw with the procedural population system. A random streak of bad dice rolls would either be incredibly exciting for some teams or a death sentence for others. To address this, we created a system that tracks each survivor's stress level by watching for events like how much damage are you taking, how many zombies have you killed near you, and so on. If a survivor's stress level gets too high, the system will step in and forcibly throttle back the zombie population system to make sure the team gets a break every now and then. These breaks are critical for a couple of reasons. The primary reason is battle fatigue. Constant fighting and gunfire is tiring. Secondly, the team needs an end to these skirmishes along the way to give them a chance to regroup, heal, and reassess. Lastly, these big exciting battles are only exciting if there are also periods of quiet, creepy, tension, and anticipation to contrast them against. This dramatic pacing is really critical to creating a fun experience. Once this system was in place, we realized we had all this useful information on how the survivor team is actually doing. From a dramatic standpoint, ideally we want to see the survivor team just make it into the next checkpoint, limping in, being chased by the horde, so they can celebrate when the door closes and they yell, "We made it."
One film technique we...
Right? So the team implemented an AI director and a bunch of systems that monitor the player and try and make sure that they always have a consistent, engaging, barely survived experience, right? Because if a team is moving too quickly and doing too well, they will get bored. The game will be trivial to them. They've already beaten the game effectively. So the game will automatically adjust difficulty and scale up to challenge the team and give them an exciting time. However, on the other side, it's not fun to be just dunked on repeatedly by the game. And so if the game notices that you're really struggling time after time and in a really, really bad spot, the game will ease up a lot to try and help you get back into the game, because it's really just no fun to get dunked on. The game's always trying to balance, right, that graph. Imagine the player's current kind of status on a graph. The game wants you to end just above 0, to where you just barely survive, right? Because that is where all the memories and excitement and, oh, we did it, yes, hanging by a thread, right? We did it. That's where all the exciting stories come from. Okay. Anyway, a real great benefit of the negative feedback loop is that it prevents runaway scenarios, right? It prevents a game from ending prematurely by helping people come back, right? Comeback mechanics. It prevents a game from getting boring. However, it can also, and this is one of the downsides of this approach, it can prevent exotic scenarios from happening, okay? Games, it feels really great to power up and then use that additional power to get even more powerful, right? That build, that progression. You simply don't get that if you have negative feedback loops that are too strong. You also can't really, a lot of people see a negative feedback loop and say, this kind of clouds the picture when it comes to skill, okay? Think about esports. Think about fighting games, RTS, right? These games will sometimes have some small comeback mechanics, but often will not. And part of that is because they don't want anything to get in the way of the just kind of pure measurement of skill, okay? And you'll see that Mario Party is not really taken seriously as an Mario Kart, in particular because of negative feedback loop. You can be the best Mario Kart player on Earth, but if a blue shell shows up at the wrong time, you're just going to lose, and it's not your fault in any way, really. And so that is one of the downsides of this approach. It's a very, very useful tool to have in your toolbox, however. Okay, I have another series of questions. What do the following have in common? Okay, chat? We'll give you a little bit more time to answer this. What do the following have in common? Compounding interest. Okay, this is what lets you retire, right? You get a bunch of money stored away. You store them in stocks often, and that helps you get more money, and then pretty soon you have enough to retire. Hopefully by the time you get too old to work, okay? Unstable equilibria, right? So sometimes in physics and mathematics, you will have something where you have some sort of system that is very stable. It appears to be very stable, but as soon as you touch it and perturb it just a little bit, it all collapses and it all falls apart. For instance, let's look back here. We have this Kirby. This system right here, this Nintendo stack, looks stable. But in fact, it is not. It is stable until we briefly touch it, right? And then I just perturb it a little bit. Oh! I perturb the system a little bit, and it cannot recover. It goes crazy in one direction, and so Kirby starts to fall, right? So unstable equilibria, and here's another example of this. This cloth simulation looks like it's doing just fine until suddenly it isn't. Look at this. So it's starting to drag. It looks great. It looks good. Oh! And it explodes. Okay, let's watch it again. This is an unstable physics system. Ah! Pretty spooky. And Call of Duty kill streaks. A kill streak, we'll take a look at one here. A kill streak is a power-up that you get after you have taken down a few opponents in a row. So for instance, if you can take down 3 opponents without dying yourself, you will unlock a kill streak, which allows you to bring in a helicopter or use an RC car to take down more opponents. Here's an example.
UAV on standby. UAV inbound.
So here's an RV car. You unlock.
RCXD ready for deployment. Friendly RCXD inbound. Hunter-killer drone ready for deployment.
Right? So it's pretty cool stuff. Very fun, and it feels incredible to get these, unlock these, get a few kills. But essentially, this is, take down opponents to get something that makes it easier to take down opponents, right? So, question: what do all of these? This is called a snowball often. So, what do all of these things have in common, chat? You've got investment, interest on investment, right? Compounding interest. You have unstable physics systems, and you have Call of Duty kill streaks. What do all of these have in common? Wait a second. What did I say? Oh, preemptively. Positive feedback loops. Whoa, hey, who could have predicted that, right? Right after negative feedback loops, positive feedback loops. You're on fire, chat. Well done. Okay, so positive feedback loops. Many people call this snowball, right? I call this runaway feedback, right? And it is essentially the opposite of what we talked about with negative feedback loops. Whereas a negative feedback loop takes the output of a system and puts it into the input and makes it more stable, right, over time. A positive feedback loop takes the change and difference in your system and it makes it more different, right? So it takes the fluctuation in your system and it helps it fluctuate even more, all right? So anyway, it's a runaway. It's a snowball. Something you did makes it easier or more likely for that thing to happen again. And so it just goes crazy to infinity. So one of the really great things about positive feedback loops is that they can be so fun and they give you a really powerful feeling of progression and control. I will tell you from experience, maybe you do not have a retirement savings yet, most of you, but I'll tell you, there is an addictive nature to watching your retirement just start to slowly go up and up and up and up and up. And you say, okay, well, this month, my retirement count in dividends made 10 cents. But next month, it's going to make 12 cents. And because of that extra money coming in, it's making more and more and more. And pretty soon, it's not cents, but dollars. And then it's not dollars, but tens of dollars. Pretty much you're buying a cup of coffee every single month for free. Then suddenly you're getting a microwave for free. Hundreds of dollars per month. Thousands, right? And then eventually you can retire. And that's how it goes. It feels great. Anyway, there is a genre. One of the bad things about this, though, is particularly in a competitive situation or in a situation where you're trying to keep player balance, this can really end games quickly, okay? If one player starts to get on a runaway or on a snowball, then the game has essentially ended and it's just going to be a GG, right? And unfortunately, if you can't GG out of a match like you can at StarCraft, then you're stuck. Like in football, in a football game, you're stuck, right? So everyone's on their phone, everyone's leaving the stadium because there's no way to just GG, play the next game, right? And there's an entire genre of games you may have heard of called idle games and clicker games that are entirely built out of this mechanic, right? All they do is they create extremely strong positive feedback loops, and it feels great. It's addictive. It's fun. And so let's go ahead and check it out, actually. So who's heard of idle games? Who's played a game like Cookie Clicker? Anyone? So this is a popular game. By the way, so this is a game we're going to play. It's called Breakout Idle. Breakout Clicker, I think. And all you do is this. Okay, I have $24, and if I want to get more money, I just click on one of these to break the block. And I get $1 for every one that I break. That's it. I'm up to $30 now. Okay, this is kind of boring, so I need some help. I want to make more money faster. So I'm going to buy a basic ball, a standard ball that bounces off walls and breaks bricks. Okay? Hey, now I have a little helper. It's a little buddy, right? This ball is making me money. Okay, well, I'm going to keep clicking, and I now have enough money to buy something to make me even more money, right? So let's keep clicking through here. We're not going to play this for too long, but I do want to show you how this starts to snowball, and it really is very fun. Okay, And you might say, you know, Austin, this does not have many decisions in it, but that's not actually that true, right? So as you gain resources, you are trying to gain resources even faster. And so the decision of what do I purchase begins to become fairly interesting, right? So I can only afford right now to buy another ball, but soon I'll be able to buy the plasma ball, which causes splash damage. Okay, so let's really go to town here. Okay, got my clicking technique going. Gonna click as fast as I can. Make sure I don't miss. Okay, we got 50 now. I'm gonna buy another ball. Can I speed this up? Can I speed this up? No, I can't. So we're gonna click around. Let's see if we can buy some upgrades. Ah, I've got more things I can buy. Oh, speed up. Oh, I can buy click. So now clicks will get me $3. Oh, no, sorry. Clicks will get me $2 for every click I make. So that's doubled my speed here. Okay, doubled my speed. Okay, so now I can go in and I can buy another one. So now I'm going to make $3 for every click I do. Okay, so you can see that's starting to snowball a little bit. We're not gaining, you know, we're not really dealing or worrying about dollars. We're worrying about tens of dollars now. Okay, so now get to 3. Oh my goodness, right? And I want to buy that plasma ball. Look at this. Look at all this. Incredible. My yellow balls aren't doing very much, but maybe the first plasma ball I get will help me out. Look at this. It moves faster, and it hits every block around them, too. Right? So now we're actually starting to move pretty quickly and building up cash quite a lot. Anyway, no auto-clicker. Can I buy an auto-clicker? Is that something I can buy? I think at some point you can buy an auto-clicker. Eventually, you can buy an upgrade that keeps the game playing while you are away. So you can close the browser, you can go to sleep, and the game will continue to make money for you over time. And that is very literally like how retirement works. Your money works for you as you sleep. There's a new ball. I can buy a sniper ball. It bounces off the nearest brick. That sounds exciting. I'm going to buy a second plasma ball. And now I'm starting to build this army up, right? Everything is just dedicated to making me more money. The money is used to buy things to help me make more money, which is used to make me to buy things, which helps me make more money, right? And so what you'll find is that it's very, very fun to play. It's surprisingly fun. The decisions you make on how to allocate that money is very fun as well, right? Because you're trying to maximize how quickly you can move. Anyway, there are entire genres of games built for this, okay? This might look like a simple game. This might look extremely simple, but I kid you not, this game has been played 500,000 times. Are you seeing this number, chat? Are you seeing this? Is this crazy or what? 500,000 plays. And you, with what you know right now, could have built this game after P1, okay? You built games that are way more complicated than this, okay? It truly is incredible. So, anyway, let's go back to it. So positive feedback loops, very, very impactful. When can they go wrong? They can ruin competition. They can end games very early, okay? Right? Mario Party is one of the biggest offenders of this. Oh, so, sorry, negative feedback loops. Negative feedback loops can go wrong because they can take skill out of the equation sometimes. So in this example, in Mario Party, there's a mechanic where if you land on a certain space, you get chance time. What happens is that a few dices are rolled, and you actually can lose all of your stars. You can go from first place that you earned through skill to last place, and it just gives all of your stars to the last place player. Very, very frustrating, and then you can feel like this. Nobody wins, super unsatisfying, boo. One of really, really interesting story where this happened, who's played the Elder Scrolls Oblivion? Okay, who's played Oblivion or Skyrim? Right? A ton of people, right? Very popular game. Well, so in Oblivion, in the Elder Scrolls Oblivion, there's a very interesting kind of negative feedback associated with how enemies work in the game and how leveling up worked. So in this game, you would level up by doing stuff. So by fighting enemies, you'd level up. And as you leveled up in the overworld, the enemies would actually get more and more nasty. They would level up with you, right? You'd start the game on low levels fighting wolves, low-level enemies, and eventually, as you got stronger, the overworld would start to become populated with stronger and stronger enemies. The result of this, for a lot of players, unfortunately, was that as you got stronger, you never felt like you were getting stronger, because the game just always kept replacing the enemies you were fighting with stronger versions. The Legend of Zelda Breath of the Wild does this too. The objective is to keep the game engaging, but the unfortunate side effect is that you never really feel like you've gotten that much more powerful, right? Because the game just scales it with you. The negative feedback loop takes away your sense of progression. But there's another interesting thing about this, because the negative feedback loop was actually implemented in a really weird way. So in this game, the enemies level up as you level up, right? However, you level up, you don't always level up based on your fighting ability. For instance, in Oblivion, you can level up by just running around a lot. You level up your running, your speed, and that causes you to level up your main kind of level. So, and same with sneaking, same with jumping. So what can happen is if you don't fight a lot in this game, your fighting skills will stay bad, but you'll be running around a lot and sneaking. So those skills will get better, but you will level up a lot. And so eventually you can get to the point where the enemies are too powerful for you to ever fight. And because you can't fight the enemies, you avoid them. And because you avoid the enemies, you don't level up your fighting skills. And it becomes this really nasty positive feedback loop where you just can't fight anything. It's a really nasty situation. Anyway, you can read up more about this unique problem with the leveling and enemy system that Oblivion has. There's some video essays on this topic, very good ones. So here's a very fun example of when negative feedback loops can go wrong. This is what it's called getting Mario Karted. Let's take a look. First place. Right in front of the finish line. Yeah, that hits you right in the feels, doesn't it, chat? Who has felt that before? Mario Kart is cruel. Mario Kart is so cruel. And so that is an example of a negative feedback loop that went way overboard in that instance and just crushed the first place player. That is painful. Anyway, so okay. Anyway, so that is all that I want to talk about there. I want to go really quickly through a short prototyping lecture because that's essentially what your P2 project is going to be. Okay, your P2 project is a prototyping project. You will have only 2 weeks, and in fact, you'll only have 1 week to get a basic prototype of your game out, and then 1 week to kind of refine it. But the prototyping process is absolutely key to the iterative development process, which means it's key to our course, okay? Key to making any decent game. This is a lecture that was actually first created by Michael Siciliano, our last speaker at the last IGDA meeting. You can actually watch the recording on Twitch if you want to. But anyway, so he essentially identified this process. So when you're making games professionally, this is the process you go through. You have an initiation where you kind of you have the basic ideas of what you want to create. You talk with some people. You get a team together that all agrees we want to make a game. We want to make a what do we want to make, chat? We want to make an RTS game, a real-time strategy game, but you only control one character, okay? And let's call it it's going to be this game full of characters that you control, and they're all going to be unique and special, kind of like a league of legendary characters. Interesting. Anyway, what you do, right, is you then go into pre-production where you kind of plan out what you want to make, okay? Right? And this is really a takeaway. How many of you, chat, I want you to let me know, how many of you actually sketched out on paper your P1 Gold custom level and custom mechanic before you implemented it? How many of you went to the whiteboard with your teammate and actually said, okay, I want it to look like this. Wait, no, that won't work. Cross that out. I want it to work like this, and then you're going to go there, and the mechanic, we're going to have enemies that do this, right? Yeah, digital whiteboard, right? A Google Doc, or you share a Photoshop, screen share Photoshop or something, right? So a lot of teams, some teams will do this, right? And they usually feel the benefits. Some teams won't. They'll just kind of jump into it. They'll just start throwing stuff together. I do that sometimes, and I almost always regret it, okay? One of the really great things about sketching and storyboarding is that it really, really, really helps you understand. And I want to bring up a slide from a different lecture. Ooh, let me see if I can find my slides. I'll show you some concept art for some games that Arbor Interactive has made. Let me see here. Scaling your production. One of the excellent things about sketches and concept art is that it helps you understand and kind of catch issues in your design before you implement the code, before you implement art assets, right? And before things get really, really expensive, okay? We'll talk about this later in another lecture called Scaling Your Production. But I want to show you a few instances of this from my game. This is actually, does anyone know what this is from? This is an actual storyboard from a movie. Does anyone know what movie this is from? G-Force? Lol, this is Star Wars. Indeed it is. This is, am I going to say it? No, I'm not. Hold on, let me bring in this other lecture real quick. We're going to show, this is a lecture you're going to see in probably a month or two. It's called Scaling Your Production. It is an awesome lecture. I like it a lot. Concept art, right? This is pre-production. The idea that we want to visualize and kind of find the bugs in our design and our approach before we commit a bunch of resources to it. So here are three storyboards for the Star Wars film, Rian Johnson's The Last Jedi. Okay, so The Last Jedi. These are storyboards from the director. Okay, he's not that much of an artist. However, when it comes to storyboarding, you don't need to have incredible visual art and drawings, right? You need to have just enough to get the idea across to others who can then take your drawings and make them into something truly beautiful, right? So he gets paid a lot more than I do. Okay, here's my sketch. Okay, this is a sketch for a bat game. A game in which we were going to have the player control a drone that flew around inside of caves and delivered little bugs to bats to feed them. Okay, and my artist essentially took this sketch that I made in my notebook and then turned it into this. She understood my idea entirely and made it extremely appealing, turned it into this beautiful kind of honeydew design with the color scheme and different colored bugs, just incredible. And here's another example of concept art for a character. And we decided, okay, we want a character. It's going to be this kind of detective girl. But she's going to have this really big magnifying glass. It's going to work as a game mechanic. She can shake it to have the display show you HUD, show you inventory. The camera will zoom in to show the inventory like this. And she can also use it to beat people. And so this is us trying to vet and see if a character is going to be really cool, right? And then later on, we devote the resources to actually animating that character. And so you can see we have some of her animations in here, if the video will play. Right? But these animations were much more expensive than the sketches were, right? She's kind of tapping her foot there, right? We got a running animation, I think. Come on, let's go. Oh, she's blinking, right? We got running in. Cool. So anyway, I think this is going to fall. Yeah, I hate this bug in Chrome. So this is concept art that my artist, Sam Olsen, whipped up in literally 2 hours. okay? And 2 hours, that cost me like 40 to 50 bucks, okay? And this design was for a match 3 puzzle game, which we would then go on to invest the resources in and actually make this game. You can find this game on the Arbor Interactive website. It did pretty well. And other things like that, victory screens and stuff like that, right? A victory screen sketch, which is done in like 30 minutes, can be turned into something much, much more professional looking when you decide that, yes, this works right here, okay? So this is the magic of pre-production. And I'm going to save the rest of this lecture for you later. We're going to go back to it. But this is the magic of pre-production, and you can use this on P2 and especially on P3, okay? You should absolutely start by sketching. Even if you're not great at drawing, it doesn't matter. All you need to do is be able to visualize your own ideas and help others see them too, okay? And help debug them visually, all right? Anyway, with games, this is a little bit difficult, okay? With games, you can try to draw sketches of what you think something's going to look like, but you don't want to just vet and verify that something will work visually. You want to verify that some game design, some set of mechanics will work together too, okay? And so we want to be able to vet in pre-production a game design before it gets expensive. So here's what we're going to do. What we're going to do is a thing called paper prototyping. So chat, have you heard of paper prototyping? This is essentially when we take your game design and we distill it down to a board game or a card game, okay? And the reason we do this is because board games and card games are extremely cheap to make prototypes of, okay? Hey, if you have a notebook around anywhere, right? If you got any notebook around you, just take a piece of paper. Hey, you need pieces, you need a game board. Go ahead and just grab a little, grab your pen nearby. Well, that's not a pen, is it? No. Grab a pen or a pencil. Okay, blah, 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 blah. Here is our game board, right? And we got little spaces everywhere. We got little places we can go. And there we go. We got a special space. And here's your game board. Boom, I just made it for you. Done, right? You know what? Do you need pieces? You need pieces to represent your characters? Okay, here's your first piece right here, right? And maybe you can draw something on that piece. And okay, oh, here's your second piece, your second character. Okay, so you can quickly make a game and visualize it, and you can actually play around. You can make cards, and you can kind of step by step go. Okay, so the enemy gets a turn now. Okay, now I get a turn. Now what does the enemy do? What do I do? This works really well for turn-based games. It doesn't work quite as well for real-time games for obvious reasons. But here are some examples, right? These are examples of little prototypes that Michael Siciliano made before he went in and actually made these games, right? So this was a game where I think it was like 4 players, and you had to take turns clicking to kind of take over more and more of the space. I forget what this is. There are other games like this, professional games that worked really well. But here's kind of a Mario clone that he sketched out. I'm not sure what he was going to do with these little balls down here. He had something in mind. Another game where I think you aimed and then shot these balls. He sketched that out. And then he also sketched out this game right here, which I actually have footage of the final version. This was designed as a turn-based game where every player would make a choice. And then when the round ended, every player would move, okay? And players could choose to go to any bucket that was nearby them. However, the catch was, as soon as players moved, whatever bucket had the most players in it sank, and all those players were eliminated. So you had to make a choice that other players wouldn't make. You wanted to make an optimal choice, but if everyone made that same choice, you would all go down, and whoever had made the non-optimal choice would continue on and win. And so here's what, where's the video for this? Is there a video? Yeah, here's the video. So he sketched this out and then implemented it in Unity. He knew this would work because he played it as a board game. He played it with a bunch of his friends, and it was pretty fun. And so then it eventually turned into this. This is a game that is played in Twitch chat. This is not a game played locally. Okay, so all the Twitch, every person in Twitch chat is a player, is a character on the game board. That just went super weird and very fast. But anyway, everyone moved here, and so a bunch of them sank. And then a few of them moved here, and it looks like they're going to win now. And some didn't move, and some moved to the right, right? Anyway, so the game works, it runs well. Michael knew it would work well. He verified the design by paper prototyping it first, okay? And so I think that's just about all I want to tell you about this topic. Sketching, storyboarding, paper prototyping, this is all a really good idea for P2, okay? A lot of you have told me that you don't have enough time for these assignments, that you end up staying up super late because you've ran out of time. You must find a way to defeat that. You must find a way to get past that challenge, to be ultra efficient. And this is another tool for your toolbox, okay? When you have a game design, see if you can verify it. Find out what the problems are so that you don't waste a ton of time, okay? If you don't waste time, you should be able to get a lot of great stuff done by the deadlines, okay? So it forces you to think about your concept deeply when you do this, when you prototype, which means you'll find stuff, you'll discover stuff, and you'll find ways to overcome stuff. And then it is also a very low investment thing. You can do this very fast if you just do it, okay? So paper prototyping, you can do this for locations as well. You can fill it with stuff. And yeah, minimal effort. You can use existing images. You can use assets. One thing we'll often do in games is we will actually take open source assets. So we might have a new character in one of our games. We're prototyping the character, so we'll go online, find an image in 5 minutes that roughly, it's the same kind of character. We'll take that image, we'll put it in the game, it will look terrible. However, it will prove that that character works. And we will then replace that character's art later with something much more professional and cohesive, okay? Anyway, be careful of the sunk cost fallacy. You want to be iterating a lot. You don't want to stick with the design. You want to discover what's wrong with your design so that you can change and pivot as quickly as possible and not the day before the deadline, okay? So use paper prototyping, and I think that's just about all I got. I apologize for going a little bit fast there at the end, but I will stick around for another 10 minutes or so, answer any questions that you have, and I will also post this agenda, okay? We'll throw some music on. Thank you all so much for waking up early and joining us. Please get some sleep tonight. Take these next few days to relax, catch up in your other courses. Remember to do your postmortem. Think deeply about what happened and what can I tweak and change for next time, okay? To have an even better result, okay? Anyway, thank you so much. We will see you next time. Let me go ahead and post this lecture agenda here. Okay, awesome. Go for it, chat. Any questions you got? Any questions, chat? Yeah, if you haven't played the posted games in the Project Progress channel of our Discord server, there are some really, really great games in there. Very surprising, very fun, very, very good level design that kind of forces the technique to become useful. Very, very easy not to get lost. There's some very impressive stuff. I can't wait to grade P1 Gold. So this laptop is an electronics branded laptop, which means that it is essentially a rebranded what is it? Clavio? I can't remember, but it's got an old kind of low end i7 processor from a number of years ago, and it also has a 1050 Ti GPU. So not the best GPU. No, only one team member needs to post the project in Discord. Rohan. But this laptop it's not the beefiest laptop. However, for having like a pretty capable NVIDIA 1050 Ti GPU and a pretty decent Intel CPU and a solid state drive, I think about 500 gigabytes. Like this was only $1,000. So that is a pretty cheap as far as gaming laptops go. And I think I discovered why it's this cheap. I think it was on sale because this particular model has big problem with its hinges. One side of the screen hinge broke, and so it's really unwieldy and it looks terrible. It looks terrible, but it's very frugal. Okay, so that's why I got it. If you did purchase some Unity assets, you can use them in your projects, but you still must credit them. Again, please do not purchase entire Unity projects. We do not want you purchasing a bunch of code, okay? This is an engineering class. You will be engineering your own projects. One of the most enjoyable things is like every evening after lecture, I go back and I rewatch the Twitch stream, to see things to improve, questions to answer. But there's a lot of very fun Twitch chat activity that I always see for the first time, and it's very, very funny. Oh, yeah. Unfortunately, I think if you build a Mac executable on Windows, it will have the permissions issue. I don't know if I've figured out I don't know if there is a solution to that, because I believe the way permissions are handled on Windows and stored on Windows is just totally different than how they're handled on Mac, which is more of a Unix-based system than Windows DOS. Yeah, so I think that's just a compatibility issue, unfortunately. I know that there's a way to fix up Mac executables. You can submit them through the App Store, for instance, and they'll definitely work. But yeah, Mac, unfortunately, Mac is becoming an ecosystem. We'll talk about ecosystems later during our business lecture. It's becoming an ecosystem where it is very hard to run things outside of the official channels that Apple provides. That is a really nice form of vendor lock-in. It is also very good for security, right? If you can only get programs through the App Store, Apple can guarantee security. They can also guarantee that you will not leave, right? So. That is very frustrating. It's almost like Mac does not allow the permissions associated with the executable to go with any upload you make. That's strange. Okay, chat, thank you so much for hanging around. Thank you so much for attending lecture. If you have any questions, feel free to post them on Piazza or ask on Discord, as you all have been doing. Otherwise, I hope you have a fantastic couple days of rest. Stay healthy, stay safe, and we will see you on Wednesday. Bye-bye, chat. Well done. Well done on P1.